During this video, I will go over every problem on your review. At any point, please feel free to pause or rewind the video. Here are the formulas for every polygon or circle that you will see on your test. If you do not have these formulas memorized, I recommend you write them down on your index card to use, as I will not be providing you with anything. On the first problem, very similar to what you're going to see on the first question at your test, you're asked to find the area of a parallelogram. Area is base times height. Remember, your base and height must always be perpendicular to each other, which means we know our base is 12, but the height we have to find. We do know that this is coming from a special right triangle, 30, 60, 90. And we know the hypotenuse is 20. And we need the side across from the 60-degree angle. So we know the side across from 90, the hypotenuse is 2x. Across from 30 would be x. So that has a value of 10, which means our height is going to be 10 square root of 3. So we would have area is equal to our base, which is 12, times 10 square root of 3. We type that into the calculator, and we get about 207, if I round off, 846 centimeters squared. So in the next problem, we have another parallelogram in which we have to find the area. Area is base times height. Remember, base and height are always perpendicular. So one dimension is going to be 12.8. And then the other one we need to find. So here we know it's a 45-45 special right triangle, which means if the hypotenuse is 6.4, that's represented by x square root of 2, where the sides are both represented by x. And here the shortcut would be to divide by 2 and multiply by the square root of 2. So we get our side is going to be 3.2 square root of 2. So we're going to multiply that together, and we get our area. Area is going to equal 57, and if we round off, 0.926 inches squared. In this next one, we're given the area and asked to find the height. We're going to use the same formula, except now we're going to plug in our area, which is 148. And we're going to set that equal to the base, which we know is 8. And then we're looking for the height, which is our unknown, which is represented by the x variable. When you solve, you go and you divide both sides by 8, and we get our height is going to be 18.5 meters, and this is our height. So if you get this on your test and it's a question, most likely it's going to be a griddable. If you get a decimal, make sure you include the decimal. If it's a whole number, that's okay too. In this problem, we're asked to find the area of a right triangle given the legs. So the legs have lengths 13 and 24. The legs are going to be the sides other than the hypotenuse, which means we have the perpendicular segments, which are needed to find area. So our area is going to equal half of 13 times 24. And then from here, you just multiply that all up, and you should get 156, and this would be feet squared. In this problem, we're asked to find the base and height of a triangle given its area. This is one we struggle with quite a bit on an exit ticket. It says the base of a triangle is 4 times its height. 4 times. Here we are multiplying. But if it says more than or less than, that is going to be adding or subtracting. It says the base is 4 times the height, which means we need to know the height to determine the base. And since we don't know the height, I'm going to go ahead and let the h variable represent the height. But the base I can rewrite in terms of h. It says it's 4 times the height. So whatever the height is, go and multiply by 4, it's going to give us the base. This is important because we can now have base and height written in terms of h. Gives us one variable to solve instead of 2 in this equation. So 48 is going to equal 1/2. I have my base, which is 4h, times my height, which is just h. Half times 4 comes out to 2. H times h would be h squared. So 48 is equal to 2h squared. Divide both sides by 2. That gives us 24 equals h squared. And then you got to take the square root. And that leaves us with about 4.899 yards for the height. And then the base, which is 4 times the height, it's going to be about, depending on where you round, 19.596 yards. This next one is talking about trapezoid. Formula for area of a trapezoid is 1/2 base 1 plus base 2 times the height. Once again, these are the perpendicular segments. Here we know our base lengths, so we know we're going to have to add 25.5 and 43.5. So this is going to be set equal to the area of 1656, and we are asked to find that height. So following the order of operations, add what's inside the parentheses first. So this is going to be 1656 equals 1/2 of 69 times h. Take half of 69 or multiply both sides by 2. I'm going to take half of 69, so it gives me 1656 is equal to 34.5 h. And then we divide both sides by 34.5. And this gives us our height is equal to 48 centimeters. So make sure you use the right formula, plug everything in correctly, solve, get your answer. This next one, area of a rhombus, is given by 1/2 diagonal 1 times diagonal 2. We know we have an area of 45 square units, and that's going to be equal to 1/2. And then we know one diagonal is being represented by 6. That's this one. And the other diagonal we're looking for is our x. So we have our equation. 45 equals 1/2 of 6 is 3. So 3x, which means x has a value of 15 units. So for this problem, we're looking to find the area of the shaded region, which means we have to find the area of the rectangle and then subtract the area of the trapezoid. So finding the area of the rectangle first, area's base, so we have 6 times our height, which is 2, and that area comes out to 12 inches squared. Then we got to go find the area of the trapezoid. So area of the trapezoid is going to be 1/2 B1 plus B2. Well, the 6 could be B1 plus B2 is just this part. This angle's 45 degrees, which means this one would be 45 degrees, which means this one's 45 degrees, making that our 90 degrees, 45, 45. So this angle is congruent to this side, not angle side. These sides are congruent, which means this is 2 units and this is 2 units. If the whole length of the rectangle is 6, we take off the 2's from both sides, and that leaves us with 2 units in the middle. And then we're going to multiply by the height of the trapezoid, which is also 2. And we get our area is going to equal 6 plus 2 is 8. Half of 8 is 4. And then 4 times 2 puts us back at 8 inches squared. Now we want just the shaded part. So the area of the shaded part is going to be the 12 minus 8, which comes out to 4 inches squared. This one here, we're asked to find the area of a rhombus. So we know the area is going to equal half. And then we're going to find our diagonals. So here is 14. And then our other diagonal comes here. Now you have to remember, diagonals in a rhombus are bisected. So if this is 25 units, then over here is going to be 25 as well. And 25 plus 25 gives us 50. So we multiply that up. So when you multiply that up, we get our area is equal to 350, and we're in feet squared. And this one, we're asked to find the area of a kite, which is the same formula for area of a rhombus. Area is equal to 1/2, and then we have one diagonal. So this one, 10 plus 10 gives us 20. And then we need to find our second diagonal. Now, kites are not like rhombuses. Only the side angles, that diagonal, is going to be bisected. So I know this one here is 10, but I need to find this length here. And to do that, we're going to have to use Pythagorean theorem. Since I know the hypotenuse is 26, and the base leg here is 10. So we do the square root of 26 squared minus 10 squared. You will have to use Pythagorean theorem on at least one of your problems off your test. Okay, so this value here, once again, it's going to be the hypotenuse squared minus the leg squared, and that comes out to 24. So the leg is 24, but I need the whole diagonal, so 24 plus 10 gives us 34. Then we go ahead and find the area. Half of 20 times 34 gives us 340. This would be centimeters squared. Question 11, we're asked to find the exact area of a circle given the diameter. Exact area is one of the concepts that a lot of you guys have been struggling with. Exact area basically means leave pi in your answer. We do have a diameter of 26, and the formula calls for radius, which means the radius is going to be half of the diameter, 13. And when we plug it in, area equals pi times our radius squared, Radius is 13. Because it's looking for the exact answer, we just need to multiply 13 by itself. And we get our area is going to be 169 pi centimeters squared. Exact area. Leave pi in your answer. And this next one, we're asked to find the radius given the area of a circle. So we have 153.9 is equal to pi r squared. Pi, you're going to divide both sides by pi. I recommend you divide by pi and not 3.14. So this is going to come out to 48.988 equals the radius squared. And we want to know what the radius is. So we're going to go ahead and take the square root. And that is going to be 6.9991. Or this one, if you're round to the third decimal spot, 7 inches. So on this one, we're needing to find the area of a shaded sector. So just a section from a circle. The directions on here, the measure of angle JKL equals 53 degrees. That's a typo. There's no angle JKL on this picture. Here we know BDA is 209 degrees. This is how it's going to be on your test. You're going to get the angle of the arc from the non-shaded part. So you're going to need to remember to get the sector, subtract from 360. So the measure of angle BCA is going to be 360 minus 209. And that's going to give us the central angle that we need to find the area of the sector. So this is going to come out to 151. So 151 divided by 360 times pi, and the radius is 18 squared. And then from there, you can use your calculator, and you should get an area of 426.942, and this would be meters squared. In this next one, we're finding the area of a regular hexagon. Regular hexagon means all the sides and angles are congruent. So our formula is going to be half the apothem times the perimeter. If it's a hexagon and the side is 5, that means we have a perimeter of 5 times 6, which is 30. Then we need to find the length of the apothem. If you do not know your angle, you have to find your sum of the angles. Okay, so your angle sum, the formula is going to be the number of sides, which is 6, minus 2, times 180. That's going to come out to 720. Then each angle, you're going to divide that by 6. That means each angle is 120. And then the apothem cuts the angle in half, making it 60 degrees. So it's a special right triangle. This is our x. We're looking for x square root of 3, which means our apothem is going to be 2.5 square root of 3. So let me go ahead. If you're not going to remember your angle sum, I recommend that on your index card, you go ahead and you put, given a hexagon, each angle is 120 degrees. So that way you know if you need to cut it in half, it'll be 60. And you can use that if you need to. Okay, so the area is going to be half the apothem, which we found to be 2.5 square root of 3, times the perimeter, which is 30. You go ahead and use your calculator to help you out and get your area, 64, and we're going to go ahead and round it to 952. This would be centimeters squared. In this one, we have like a composite figure. You're going to have a couple of these on your test. So you got to kind of break up your picture. And here, I can make out about 3 rectangles. So starting here, this rectangle, I know is going to be 1 times 2.5, because that's base times height. 1 times 2.5 comes out to 2.5. And then I have this area here. In my dimension, I have 1. And then I don't want the whole 3.5. I just want this piece here. So this is 1, and this is 3.5. The whole thing's 3.5. Then 3.5 minus 1 would be 2.5. So area is going to be 2.5 times 1, which also comes out to 2.5. And then the last section, once again, I don't need the whole segment. I just need this little piece here. So the whole thing is 3. 3 minus 1 is 2. So area is going to be 2. And then I just need this little piece here. If the whole thing is 3.5, it's going to be 3.5 minus this one and this 2. So 3.5 minus 2 is 1.5. Minus 1 is just half. So 2.5, 2 times half. This gives us an area of 1. And then I can go ahead and find the area of the entire figure by adding my 2.5, 2.5, that should be a half, and 1. And that gives me area is 6 feet squared. For number 16, this is another composite. I have half a circle, so I'm going to take my area of a circle and divide by 2 because I just need half of it. So this means the area is going to equal 1/2 pi and then my radius is going to be half of the diameter. Now I'm not given the diameter, but I do have some dimensions for the trapezoid. I know the whole base here is 36 and the top is 22. So I can use that 36 minus 22 gives me 14. So that means from here to here is 14. And I know this is a right triangle, which means we can use Pythagorean theorem. So the height is going to equal the square root of 21 squared minus 14 squared. Well, my height is going to be about 15.652. And then I need half of that to be my radius. So we have a radius of about 7.826. So the area of our semicircle is going to be about 96.205 inches squared. Then we can go ahead and find the area of the trapezoid. And we'll follow our formula. It says area equals 1/2 the sum of our bases times the height, which we found to be 15.652. Following your order of operations, and we get an area of 453.908. And then our last step, since we're finding the area of the whole figure, we're going to add our two numbers together to give us our final answer of about 550.113. This would be inches squared. So in the next one, we're asked to find the area of a regular octagon, which means all our sides are congruent. So if we're looking for our perimeter, perimeter is going to be that 3.5 times 8, which means we have a perimeter of 28. And then we got to come and find our apothem. So our apothem is going to be from the center of the polygon perpendicular to the base. We got to find our length. So .5 divided by 2 is going to give us our side length here. And we're going to use that, either trig or special rights. We got to find out the measure of this angle. So if it's an octagon, that means we're going to have 8 minus 2 times 180. That's going to give us the sum of all the angles. So that comes out to 1,080. But then that we divide that by 8 to get the measure of each angle. Each angle is 135. And then you divide that in half. And that gives us 67.5. So here we're going to have to go ahead and use trig. We have the adjacent, and we're looking for the opposite. So, SOHCAHTOA. This is going to be TOA. So we have tangent of 67.5 equals our opposite, which is what we're looking for, over our adjacent. And our adjacent has a value of 1.75, which means x is going to equal 1.75 times tangent of 67.5. Remember, whenever you're using trig, you want to make sure that you are in degrees. So here I get a value of 4.225 if I round to the third spot. So my apothem is 4.225. Now I can go and plug everything in. Area is going to equal half of my perimeter times my apothem. Perimeter is 28. Apothem is 4.225. So this gives us about an area of 52.813 millimeters squared. Okay, on this problem, we're asked to find the area of a section of an orange. Orange is circular, so we're going to use area is equal to the central angle divided by 360 times pi r squared. It tells us the diameter is 9 centimeters. Well, this cannot be a real orange. So the whole thing is 9 centimeters. The formula calls for the radius, so the radius will be half at 4.5. And then, since the orange is divided into 10 sections, the angle, our central angle, is going to be 360 divided by 10, which is 36. So our central angle equals 36 degrees. From here, we can find our area. Area equals 36 divided by 360 times pi times our radius, which we said is 4.5 squared. So we get an area of about 6.362 centimeters squared. Oops. Okay, so on this one, we're making similar patios. The perimeter of the original patio was 114. The new is 171. So the perimeter is going from 114 to 171. And then it's asking us to find the area of the new patio, given that the area of the original was 722 square yards. So the first thing we need to do is figure out what is our scale factor. Remember, scale factor and the ratio for perimeter is the same. So if you're able to reduce 114 and 171, so 114 divided by 171 is 2/3. And then for the area, we're going to take that 2/3 and square it, which means the scale factor for area is going to be 4/9. So we have 4/9. We set it equal, okay, so it's the original, so that 722 is going to go in the numerator, and we're looking for the area of the new. So you cross multiply, we get 4x equals 6,498, which means x has a value of 1,624.5 yards squared. In this one, it says the perimeter of a drawing is 14, where the actual building is 63. So 14 to 63. And then you're asked to find the area of the actual building. So here we take the perimeter and reduce. We get our scale factor is 2/9. So we have 2/9, and we're looking for the area of the actual storage. If the drawing is 14, then we're looking for x. So 2x is going to equal 9 times 14, which is 126, which means the area of the actual building is going to be about 63 square feet. Okay, and in this last problem, we have a rectangular yard with the dimensions 24 feet by 52 feet. Winnie has a similar yard. We know the area of Winnie's yard is 75,000 square feet, and we're looking for the dimensions of her yard. So this one we're going to have to solve twice. So if we take June's yard, the area of June's yard is going to be 24 times 52, and that comes out to 1248. So the area is going to be 1248 for June against Winnie's, which is 7,500. So if I go ahead and I reduce, I get 104 over 625. And remember, area, that's our units are squared. So if I want the scale factor, I take the square root. So my scale factor, 104 doesn't divide evenly. So square root of 104, or if you want to use a decimal, you can. The square root of 625 is 25. So I'm going to do the square root of 104 over 25, and I'm going to set that equal to one dimension, 24 over x, cross multiply. And we get x has a value of about 58.835. So that's going to be one dimension. Then we got to do the same thing but with the other. So it's going to be the square root of 104 over 25 is equal to 52 over x. X equals the square root of 104. And then 52 times 25 is 1,300, which means x has a value of about 127.475. So this one, once again, you had to find your scale factor, and then you had to solve twice, two different proportions, one for each dimension, one for the base and one for the height. This is exactly how the last question in your test is going to be. You're going to have to solve two proportions to get your dimensions.